Hello friends, today we'll find the kinetic energy, speed of alpha particle emitted in alpha decay. So this is a concept of collision. This is before decay, this is after decay. This is a parent nucleus, daughter nucleus, alpha particle, and Q energy released. Okay, so we'll apply the law of conservation of linear momentum. Okay, so apply the law of conservation of linear momentum. Law of conservation of linear momentum. Okay, law of conservation of linear momentum. So md vd plus m alpha v alpha is equal to 0. So we need to add the momentum of daughter nucleus and momentum of alpha particle, that is a helium. So momentum of helium, momentum of daughter nucleus. Now what we'll do, we'll need to find the vd. Why? Because we will substitute in the further equation. So vd is equal to minus m alpha v alpha divided by md. Okay, so let it as equation 1. Okay, to take as equation 1. Now move to the another page. So what we had from the previous page is like vd equal to minus m alpha which is not clear due to it's not being visible, not visible. Okay, look 1 second. Okay, now what we got from the previous page is m alpha v alpha md, equation 1. Okay, this is what we got from the previous page. Now apply the law of conservation of energy. Law of conservation of energy. So apply, which is the kinetic energy. So same like first of all we have to add the two kinetic energy of daughter nucleus and alpha particle. So md vd square, kinetic energy of daughter nucleus, and this is kinetic energy of alpha daughter nucleus. This is the kinetic energy of alpha nucleus is equal to q, the energy released. Okay, now what we'll do, we'll substitute the equation 1 in vd. Okay, in equation this is equation 2. Substitute the equation 1 in equation 2. What we'll do, we will substitute the vd here. So let's substitute. So m alpha v alpha by md square plus half m alpha v alpha square is equal to q. Okay, so what we'll do, so just we have to take this square. Okay, md equal to m alpha square v alpha square by md square is equal to, right as it is, of another term. So what we'll do, this 1 md will cancel here, and we're left with, now take a common. Okay, now take common, like half m alpha v alpha square will be common. Half m alpha v alpha square will be the common. So we're left with m alpha here divided by md plus 1 equal to q. Now what we'll do, we can term this as a kinetic energy of alpha, ke alpha. Okay, ke alpha. So this is ke alpha, and what we'll do, now we'll put like here, come here, like m alpha equal to the mass of alpha particle, that is the mass of helium. We know the mass of helium. Mass of helium is 4. Okay, so 4 its unit is AMU. So MD, what is the mass of daughter nucleus? To come to the beginning page, the mass of daughter nucleus is A minus 4. Okay, A minus 4. So write A minus 4 here, and now put the value M alpha and V alpha here. So it is like 4 by A minus 4 plus 1. Okay, now simplify. So here I am simplifying. Ke, that is kinetic energy of alpha, A minus 4 A minus 4 equal to Q. So here 4 will get cancelled, and now what we'll do, so Ke, that is K of alpha, kinetic energy of alpha particle equal to Q. Take this shift this in another side, so A by 4 by A. So this is a kinetic energy. We found the kinetic energy. So we're done with the kinetic energy. Now we'll find the speed V alpha. Okay, so let's go. So what we find from the previous is like Ke alpha equal to A by 4 by A Q. Okay, so this is what we gonna find. We did find. Okay, now what we'll do, we'll write the proper form, like K alpha means what, half M alpha V alpha square is equal to A by 4 by A into Q. Okay, now what we'll do, we'll find the, what we'll do, we will separate half M alpha from here. Okay, so this will be this. Okay, now what we'll do, V alpha take a square root. So this is our velocity of alpha particle. Okay, so this is what we'll find the velocity of alpha particle. We're done with velocity of alpha particle. Thank you.